Hello, let's start with section 2.5, which are higher order derivatives. Okay, so if f of x is x to the third minus 6x squared plus 2x minus 7, we can get the first derivative, that's f prime x. So that is 3x squared minus 12x plus 2. Okay. If we differentiate again, or take the derivative again, so I'm going to take the derivative of this function, bring the 2 out front, so you get 6x minus 12. Take the derivative again, you get the derivative of 6x, which is 6, and the derivative of 6 is 0. So these are called higher order derivatives. We have the first derivative, the second derivative, the third derivative, and the fourth derivative. So we call this, the first one is f prime x, f double prime x, f triple prime x, the fourth derivative of x, and so on. If we keep on taking the derivative of this function, the fourth and fifth and sixth derivatives, there will be the derivative of 0, which is 0. Okay. So let's look at this function, which cannot be differentiated down to 0. And it says find the first 5 derivatives. Okay. So this we're going to rewrite as x to the negative 1. Okay. Now the first derivative is negative 1 x to the negative 2. Okay. And I'll convert those later. The second derivative is, so the negative 2 comes out front, so we get positive 2 x to the negative 3. The third derivative, excuse me, of x is the derivative of the second derivative. The negative 3 comes out front, so we get negative 6. Whoops, what happened? Negative, whoops, something is going on. Negative 6 x to the negative 4, because remember we're subtracting 1 from the exponent each time. And then the fourth derivative, now the fourth derivative you can write it like this. So you see this note below, it says a 4 in parentheses means the fourth derivative, while a function without the parentheses means the fourth power. Okay. So instead of writing 4 tick marks, I can write f to the fourth in parentheses, which is the fourth derivative. The negative 4 comes out front, so we get positive 24 x to the negative 5th. And then the fifth derivative, the negative 5 comes out front. What is that? So 20 times 5 is 100, and 5 times 4 is 20, so that's 120. Negative 120 x to the negative 6th. Okay. Now I'm going to convert these. My original function, it does not have any negative exponents, so my answer should not have any negative exponents. That's the general rule of thumb. So I'm going to rewrite this as negative 1 over x squared, 2 over x cubed, okay, negative 6 over x to the 4th, 24 over x to the 5th, and negative 120 x to the 6th. Okay, and if you keep going, our numerator will get larger, or the numbers will get bigger, and then the denominator will just keep increasing in power. Okay. Let's look at velocity and acceleration. So this is a practical application of higher order derivatives. Now remember, a derivative equals the rate of change, right? Instantaneous rate of change. So if we call s of t the distance at time t, v of t, the velocity, is the rate of change. And I just write rate of change, ROC, rate of change of distance with respect to time, right? With respect to time. So the rate of change of distance means the derivative of the distance. And that's what we have here. The velocity is the rate of change of the distance. Similarly, the acceleration is the rate of change of the velocity, so that's the first derivative of the velocity, which is the derivative of the position or distance. So that is the second derivative of the distance. Okay? Let's do an example. So we have a delivery truck driving along a straight road. and after t hours, its distance in miles east of its starting point is this function right here. Okay, so they give us the distance function. We need to find the velocity function. So v of t is s prime t, okay, the derivative of the distance, which is the derivative of this guy, 20, so that's 48t minus 12t squared. Okay, and it says find the velocity of the truck after 2 hours. So we need to plug 2 into this function. Okay, so that's 48 times 2, which is 96, minus 2 squared. Remember exponents first. 2 squared is 4, times 12 is 48. 96 minus 48 gives me 48. And my units are miles per hour. So after 2 hours, the velocity of the truck is 48 miles per hour. It says find the velocity of the truck after 5 hours. Okay. So find the velocity of the truck after 5 hours. So we already have v of t. 48 times 5 minus 12, 5 squared. So for this, I'm going to use the calculator. 48 times 5 minus 12, 5 squared. Negative 60. So negative 60 miles per hour. So this is interesting. How can I have a negative velocity? Well, if you remember, the truck is going east of its starting point, right? So if you get negative velocity, that means it's going in the opposite direction. So this is going 60 miles per hour west. It's headed back to its original position. And this is 48 miles per hour east, okay, going in the positive direction. So here we're calling positive east and negative west. It says find the acceleration of the truck after 1 hour. Okay. So the acceleration is the derivative of the velocity function. So that's the derivative of the velocity function is 48t minus 12t squared. So that is 48 minus 24t. And it says find the acceleration after 1 hour. So that's 48 minus 24 times 1, which gives me 24. And the units are miles per hour squared, right? So think about this. The velocity is miles per hour. The acceleration is hour, so it's miles per hour, right? And then when you divide fractions, you multiply by the reciprocal. Miles per hour squared. Okay. Let's look at example 6 in your book, predicting population growth. So here is the example. Let me see if I can skip this up a little bit so you can see. Okay. So the United Nations demographers predict that 2 years from the year 2000, the population of the world will be given by this function, million people. Find p prime of 16, p double prime 16, and interpret these numbers. Okay. So p prime of 16, the derivative of 6250 is 0. The 3/4 comes out front, so we need to multiply 3/4 by 160. Okay. We get 120. So that's where that 120 is coming from. T to the 3/4 minus 1 is minus 1/4. So it says p prime of 16, you plug 16 into the function. Now remember, this is the 4th root. So this is actually saying, let me come over here and find some space. So if I have, go back, 120t to the negative 1/4, it's actually 120 over t to the 1/4, which is the 4th root of t. Then you plug 16 into there, if I plug 16 into here, then that's the 4th root of 16, which is 2. 120 over 2 is 60. Okay. And actually, I think there's an error here because somehow they messed up. So there's a typo in the book. It should be 120 times a half, not 160 times a half. So you should get 60 here. Okay. So that means in 2016, the world population will be growing at a rate of 80 million people per year. So the first derivative tells us the growth rate, right? The rate of change of the number of people. The second derivative, again, you pull the 1/4 out front, you get negative 30, t to the negative 5/4. When you plug in 16, you get negative 0.94. Which means that although the population is growing, it's growing slower, right? So the fact that the first derivative is positive and the second derivative is negative means that the growth is continuing but more slowly. So the second derivative tells you the rate of change of the first derivative. Okay. After 16 years, the growth is decreasing by about 0.94 million people. So even though the population is growing, the growth itself is slowing down. Okay. Let's go back to our notes. So look at this. The newspaper headline on the left says that productivity grew. That means the first derivative is positive, but more slowly. That means the second derivative is negative, following a curve like this. Okay. So basically, you can have some curves, like 6 different curves, right? If your first derivative is positive, that means you have growth. So you can have growth like this, which means steady growth, right? The acceleration will be 0. Or you can have growth like this, or you can have growth like this. Okay? If your first derivative is negative, means you can have, what is that called? Not growth, but decrease, loss, going down. Okay, that's constant acceleration or constant second derivative, or the second derivative is 0. Or you could go like this, where your loss or your decay is speeding up, or your loss and decay is slowing down. Okay. There's a picture like this in the book. We'll see in a few sections that explains this better. Okay. So for each headline, sketch a curve representing the type of growth and indicate the signs of the first and second derivative. So consumer prices rose in October, but at a slower rate. So if consumer prices rose, that means the first derivative is positive, but at a slower rate. That means the second derivative is negative. So what is that going to look like? That's going to look like this. The first derivative is positive, and the second derivative is not 0, so it cannot be a straight line. First derivative is positive, but it's slowing down, so it has to look like this. Okay. Households still shrinking, but the rate is slower. So that means the second derivative, or first derivative is negative, rate is slower. That means the second derivative is also negative. Okay. So that means it's shrinking, so the first derivative is negative, it has to be going down. So this goes down, this goes down. But the rate is slower, so if it's slower, it looks like this. Okay. If it was faster, then it would look like this one. Alright, so that is it for 2.5. We will continue on with 2.6, which is the chain rule, and then we will go into exponents and derivatives of exponents and logs.